So a bus is just like it sounds, it's just one long cable, and then the computers or the devices will have drop in at specific places. You can have a linear bus, which is just one cable, or you can have a tree topology, which is you have the one cable and then you can have other cables going off of it. Now if you have a linear bus, just one cable, that's a single point of failure, because if that cable goes down, then the computers can't be communicating to each other. So in a bus situation, that if that cable goes down, that's a single point of failure. It's simplistic. It's not necessarily what we use. We use a lot of star topologies today that we'll talk about. Now a ring topology, is this the same thing as a token ring? No, because a ring is the actual physical way that computers are connected to each other. They're actually in a circle, they're in a ring. Token ring is a technology that works at the data link layer. It has nothing to do with the physical topology. So a ring is just means that there's a circle set up, and then you have the devices connected to the cables that are providing that circle. So a potential downfall when you're using a ring topology is that if one system goes down, that can negatively affect the downstream system. So if the data is traveling this way, this computer goes down, this other computer may not get any data. Now, this is at the physical layer. This is not at the data link layer. Our networks today are not this vulnerable, that if one computer goes down, then basically all networking stops. We have protocols at the network layer that are smart enough to know how to basically kind of shut that section off and bring the network together. So when I say that the downfall or issue is if one computer goes down, the next computer may not receive its data, that's at the physical layer, physical. And that's why we have kind of intelligence built into the data link layer protocols to deal with these potential physical issues. Now the star is you have some type of central device. It's usually a switch today. We use switches usually. It could be a bridge, but a star just means that you have devices connected to the central device. And that's what we use today. We use star, collapsed stars, those types of things. So what would be a problem if we're using a star topology? Well, if that central device goes down and everybody's communicating through it, that would be the single point of failure. So they're all dependent upon this one switch, let's say. And that's, jumping ahead a little bit, but that's why we have to have redundancy within our network, so we don't have single point of failures. And we talk about redundant technology like in operations and business continuity domains. So the last topology is referred to a mesh. And basically a mesh means that it doesn't match any other things I just talked about. It's not a bus, it's not a ring, it's not a star. Systems are just connected somehow. And like, for example, the internet is a mesh network. It's not a ring, it's not a bus. Computers and systems are just connected somehow. Now that would be a partial mesh. That would be, internet would be an example of a partial mesh. Now a full mesh means that every computer has a direct connection with every other computer. So if you think about it, let's say you and I and one other system are on the network. I would have a link to you, and I would have a link to that other system. And let's say we add a system. Now I have a link to that system. I actually have a physical cable running to each one of these systems. Now that provides an amazing amount of redundancy, but it's very expensive. So full meshes aren't common for a whole network. What they're common for is when you have some type of critical devices that need to continuously communicate, and you put in redundancy, which means that they have more than one cable for communication. So again, a mesh is a very popular. This is what we usually use either when we're doing cellular communication, when we're doing wireless communication, fiber communication. It can be a ring, but meshes are pretty common because it doesn't follow a specific structure. This is, you know, a lot of the stuff that we cover in CISSP is not difficult. It's not complex. But as I've said in other domains, is that what you're going to be faced with is some type of question that's a little slippery. It's not going to say specifically what is a bus topology or what is a star topology, and you're going to answer it. It's going to be a little bit trickier. It's going to be a cognitive question, and you're going to have to pick out the best answer. You may not agree that it's the right answer, but it's the best of the four. So not only do you need to know the definitions of the different topologies, you also need to know the issues that we discussed. If there's a single point of failure on a bus, that would be the cable. Single point of failure for the star would be the central device. So that seems straightforward, and it is. It's not difficult. But just don't blow the stuff off, because that information is going to be wrapped up in some type of a tricky question. So make sure you understand specifically what I'm talking about.